Welcome back. Thanks for joining me again. So in this lesson, we're going to review some common terminology that you're going to run into as you work with cloud. The first term that we're going to review is scalability. When something is scalable, it gives you the ability to easily grow in size and capacity and/or scope based on demand. So in our example, we have 1,000 users. And due to the demands of our business, we are scaling or growing up to 2,000 users. So we need to scale our environment to have appropriate capacity to support the 2,000 users. So we add an additional set of server equipment. Now, our environment continues to grow and it grows to 6,000 users. This is scalability, that ability to continue to add additional capacity to meet those requirements. But what happens if we overprovision? What happens if we didn't really need these last two sets of servers? Well, in this example, we've already paid for this additional capacity, so it's wasted money. So when something is scalable, you can grow it based on demand, but if you overestimate, you essentially have wasted capacity. And then there's a term called elasticity. When something is elastic, it can grow, but it can also shrink. So this makes me think of a rubber band. You stretch your rubber band, it stretches, it snaps back. It's elastic. Boogie, woogie, woogie. I don't know why this always makes me think of the Electric Slide song, but elasticity allows you to grow and shrink on demand. So we go from 1,000 users to 2,000 users, and we add that additional capacity, but for some reason, we shrink to 1,000 users. And as a result, we now have this unused capacity that we don't need anymore. Well, because we're elastic, we essentially remove that additional capacity. We don't have to pay for it anymore. We don't have to have that unused capacity just kind of hanging out there. We're able to remove it. And when you're using cloud services that are elastic, that means that you don't have to pay for that unused capacity. And then we have the terms fault tolerance and high availability. When something is fault tolerant, it has the ability to withstand a certain amount of failure and still remain functional. Basically, it can self-heal, or it has a way to return itself to full capacity. An example of this might be a home network. We have this home network with multiple computers, and we have this router. Now let's assume that we have 2 ports on this router. If one of those ports were to fail, then we could continue to use the internet because the second port is able to pass the traffic. That means the router is fault tolerant. When something's highly available, we're able to continue to use that service. When we attempt to access it, it's there. We basically are able to bypass a failure because we have multiple routers, as an example. So if we were in a situation where we had 2 routers and we had connectivity between both of those routers, if one router were to fail, the second router could continue to pass the traffic. That would be an example of high availability. We're still able to access the platform and we don't have a single point of failure. If there's a single point of failure anywhere within the environment, then it's not completely highly available. You can have high availability at different levels, but ultimately, if there's a single point of failure, it impacts your high availability. And our router in this example is our single point of failure. So that's the difference between fault tolerance and high availability. All of these terms are things that we're really going to be talking about as we continue to go through the course. So I wanted to take the time to review these terms with you. Thanks for watching. I'll see you in the next lesson.